Hey guys, in this lesson we are going to find the areas of trapezoid, rhombus, and kite. In this first video we will focus on trapezoid. The height of a trapezoid is the perpendicular distance between its bases. Trapezoid has two bases. They are the parallel sides. So here's a base and here's a base. The height is this perpendicular distance between them. Okay, so we can't use these slanted sides as the height. They have to form 90-degree angles with each base in order to be a height. So I could have a height over here. I could have a height out here as long as it's perpendicular to both bases. The area of a trapezoid is half the product of its height and the sum of the lengths of the bases. Okay, so the area formula is half times the height times the sum of the bases, base 1 plus base 2. And what's happening here is when we do half and then times base 1 plus base 2, we're finding the average of the two bases. Okay, so it's the height times the average of the two bases. The free throw lane in an international basketball court, like in the Olympics, is shaped like a trapezoid. Find the area of the free throw lane. Okay, so we've got a 3.6 meter free throw line, and then along the baseline, the key is 6 meters wide, and it's 5.8 meters from the free throw line to the baseline. Okay, so the area is half times the height. The height is the distance between the bases, which is 5.8. And then that's times the sum of the bases, which are 3.6 and 6. 3.6 plus 6. Okay, so 0.5 times 5.8 times 3.6 plus 6. 27.84. So the area of this free throw lane is 27.84 meters squared. Here's the map of a city park. Each grid is a 10 by 10 meter square. So notice on the coordinate plane here, 1 unit counts for 10 meters, and 1 unit this way also counts for 10 meters. To find the area, we'll count by tens, 10, 20, 30, 40, 50, 60, 70. So this is 70 meters. 10, 20, 30, 40. The base up here is 40 meters. The height is 10, 20, 30, 40, 50 meters. So the area is half times the height, which is 50, times the sum of the bases, which is 40 plus 70. So 0.5 times 50 times 40 plus 70. We have 2,750 square meters. So we'll find the area of this trapezoid. Now this one of the sides here, one of the legs is perpendicular to the bases. And that means we can use that leg as the height. If a leg is slanted like this, we cannot use it as a height, but because this one is perpendicular to the bases, we can. So the area is half times the height, 4, times the sum of the bases, 6 plus 8. And that is 28. So we have an area of 28 feet squared. Okay, next we have the two base lengths. We have the area. We want to find the height of the trapezoid. So I want to know this number right here. I'll call it h for height. So the formula is area equals half times height times base 1 plus base 2. In this case, we know the area, so we're going to put that here, and we know the bases. We'll fill those in. So for area, we put 160 equals half times the height, which we don't know, times the sum of the bases, 18 plus 25. Okay, so we can add 18 and 25, and that's 43, times half is 21.5. So 160 equals the height times 21.5. Okay, so that's adding 18 and 25 and multiplying by half, we get 21.5. So now we can divide by 21.5 on both sides. And we get the height is 7.44. And that is in feet. Okay, now this time we are missing one of the bases. We have a base, we have the height, we have the area, but we don't have this other base. So the area, 128, equals half times the height, which is 8, times the sum of the bases, which is 12 plus, we'll just call it B for base. Okay, so half times 8, we can do that. We get 4 times 12 plus the base equals 128. Well, we have some options now. We can distribute that 4, or we can divide both sides by 4. I'm going to go with that option. I will divide both sides by 4. 128 divided by 4 is 32. So we get 32 equals 12 plus the missing base. And then we can subtract 12, and we get 20. And that is in inches. So the missing base is 20 inches.